We now find the position function of the particle given its velocity function. That is, v of t is given as sine omega t times cos power 7 omega t. So let's see how to find the position function. So we write down the position function, that is x equals f of t, and this is basically the integral of the velocity function. So we put integral of velocity function, that is v of t dt. So let's replace v of t by this given function, that is sine omega t times cos power 7 omega t and then dt. So basically we have to evaluate this integral. Let's see how to do this. I'm going to use the substitution method. So I'm going to put cos omega t, this equals u. And now I take the differentials on both sides. So therefore, the derivative of cos omega t is the derivative of the cos function is a sine function, negative sine function. So we put a negative sine of omega t, and then when we apply the chain rule, we find the derivative of omega t. The derivative of omega t is just omega. So I put this omega, and then we have to multiply with dt, and this equals, so on the right side if we take the differential of u, we get du. So here I'm going to solve for sine omega t and dt. I'm going to solve only for this expression so that I can replace in the original integral. So for that I need to divide both sides by omega. So I have sine omega t dt, and this equals, I can write down this as negative du divided by omega. So I have solved for sine omega t dt. And this means when I go back to my original integral, I can replace this sine omega t dt. This is, I can replace by negative du over omega. So therefore, our position function, that is x equals f of t, and this equals in terms of u function, this is equals negative du by omega. I put this negative du by omega. Now I replace for cos omega t. If cos omega t is u, then cos power 7 omega t, this is, we can raise it to the seventh power, cos power 7 omega t, and this equals u power 7. So I can replace u power 7 for cos power 7 omega t. So basically we have to evaluate this integral. If we put very next to it, I'm going to factor the negative 1 by omega. So therefore this becomes a negative 1 by omega, where omega is a constant, integral of u raised to the power of 7 and then du. Now we can use the power rule of integration. That is, if we have to integrate x raised to the power of n dx, according to the power rule, it is x raised to the power of n plus 1 divided by n plus 1 plus the integration constant c. So when I use this rule over here, I put this negative 1 by omega multiplied by u raised to the power of 7 plus 1 divided by 7 plus 1, and then I put this integration constant c. So let's simplify this. This becomes negative 1 by omega u power 8 divided by 8 plus the integration constant c. And since we know that u is cos omega power t, cos omega t, we can replace for u here. So therefore this becomes, I can combine these two and write down this as negative 1 by 8 omega, and this is cos power 8 omega t, and then I put this integration constancy. So now we obtain the position function in terms of t, that is x equals f of t equals negative 1 by 8 omega cos power 8 omega t plus c. We will use the initial condition, that is given that f of 0 equals 0, that is at t equal to 0, f of 0 equals 0. So we replace t by 0, and this becomes we will get f of 0, and this is also 0. So this becomes f of 0. We know that f of 0 equals 0. So we put 0 equals negative 1 by 8 omega cos power 8 omega t is replaced by 0 plus the integration constant c. And we know that the value of cos of 0, this will be cos of omega times 0 is 0. So it is cos power 8 0. We know that cos power 8 0, this is equal to cos 0 raised to the power of 8. So cos 0 is 1. So 1 power 8 is 1. So basically the value of this expression is 1, which I'm going to replace here. So this becomes 0 equals negative 1 by 8w times 1 plus c. And from this we can easily uh, calculate the value of the integration constant by adding this 1 by 8 omega. So basically c equals 1 by 8 omega. So we have determined the value of the integration constant c, and that equals 1 by 8 omega. So all that we do now is we go back to this function which we have already determined and substitute the value of the integration constant c. So therefore we write down the position function x, and this equals in terms of the function of t, this equals, the first expression is cos power 8 omega t. I write down this as cos power 8 omega t, and this is basically a negative quantity, so it is negative of cos power 8 omega t divided by 8 omega plus the integration constant c, that is 1 by 8 omega. So this expression gives the position function in terms of t. Or else, since we have the common denominator of 8 omega, we can combine and rewrite this as, I put this 1 in front. So it is 1 minus cos power 8 omega t. This is all over 8 omega. So we can consider this as the final expression for the position function in terms of t.